All right, today's lesson is on the chain rule. The chain rule is sort of an extra part of the derivative rules that we've been using, and it's going to be basically a function within a function. So you're going to be looking at something like this. Now, this is the sort of theoretical idea of what the chain rule is. We've got a function h of x, and that function is made up of two individual functions. A function within a function. So g is sort of a function within the function f. Right? And then when we take the derivative of this, we have to take into account the fact that we are dealing with two different functions. We're dealing with the function f, and we're dealing with the function g. So the derivative of this, which would be h prime of x, here, h prime of x is equal to, I take the derivative of f first, with no regard to g at all. So it's the derivative of f times g of x, the derivative of f at g of x, I'm sorry, times the derivative then of the g. So what that's basically saying is I want to take the derivative of the whole function and then take the derivative of the inside of the function. And that's kind of what the chain rule does. It's a little bit confusing here, so let's look at a couple examples, and maybe this will make it easier to deal with. All right, so here's a really, really good example of the chain rule. It looks very easy. It looks like the derivative should be cosine 2x, because we've already done the derivative of the sine as cosine. But in this case, I not only have the x, but I have a 2x. And so I have to deal with that 2x as an extra function when I'm going to take the derivative. Because when I go to take the derivative here, f of x is just like our h of x from the other page. So f of x becomes f prime of x. So I've taken the derivative. I'm taking the derivative of the function I have. The function I have is sine 2x. So if I think about the chain rule from before, the f of x, this is like our h of x here. Our f of x would be the sine function. We'll just say sine of x. And then our g of x is the 2x. So those are your two functions that you're dealing with. And so I have to take the derivative of both. I have to take the derivative of the sine, and then I also have to take the derivative of 2x. So when I go to take the derivative here, this is going to be equal to, well, what's the derivative of the sine? Well, the derivative of sine is cosine. So it's the cosine of what I have, not x, but the cosine of 2x. So now I've just taken the derivative of the sine. That's the first part. And that would be great if this wasn't 2x, but it is 2x. So I have to deal with that 2x. And the derivative of that 2x is then 2. And so if you notice, if I go back to the other screen, that's kind of what we have. F prime of g of x is the cosine 2x. The g prime of x here is our 2. And that's how the chain rule works. And then what we can usually do is kind of simplify this. We put the 2 on front so it's not getting confused with the 2x. And we say cosine 2 cosine 2x. And that's an example of the chain rule. So let's look at another one. All right, so here we've got a g of x, and again, the function that I have on the left side can be any variable. It could be h of x, g of x, f of x, doesn't matter. But in the original, this would be considered as our h of x. If I'm looking back at our original theoretical way to do the chain rule, our g of x, our f of x this time, is kind of hidden. You don't really see it, but it's actually that whole parenthesis cubed. Or we can just put an x in there. That's like our x cubed. The cubed part is our f. And then our g, the function inside, is the 2x minus 5. Okay? So now, when I go to take my derivative, gx becomes then g prime of x. The first thing I have to deal with is that cube. And we know by the power rule, the cube would be the 3 has to come down, and then we take 1 less than our exponent. So now I have 3 times 2x minus 5. Notice I'm not doing anything with the inside, raised to the second power. So I've done the f part. Okay? Now I have to do the inside. So the inside, the derivative of the inside is our 2x minus 5, and the derivative of that, again, in this particular case, was 2. Now, that's all fine. We're done. We've used the chain rule to find the derivative. Now, as I talk about a lot in class, As a multiple choice problem, that would not be the answer. They're going to combine those constants. And you end up with a 2 times the 3. You get 6, 2x minus 5 squared. And that would be another example of the chain rule using the power rule instead of the trig that we did before. Okay? All right, so one more. Let me give you one more example. A little bit different again. It's using those same rules, the power rules and those differential rules we've already had. And that's this one. And again, if you want to pause the video to try this one on your own, that'd be great. If not, let's go ahead and continue. So I've got my h of x just like I had in the original. And let's go back to it real quick. Let's just make sure we understand. This is our h. Our h of x is a function f and then something inside f, g of x. So those are the two things you have to identify. You don't have to necessarily list them, but it's always a good idea at the beginning when you're first learning it to list them, because sometimes they're hard to see. Now in this case, we don't take derivatives with a root. What do? Well, we change them into a fractional exponent. So I want to think of this as 4x squared plus 1 to the 1/2 power. Now we can see our two functions, hopefully. Our f of x would be whatever is in the parentheses raised to the 1/2 power. And you put an x in there if you'd like. It's really that 4x squared plus 1. But I'm only dealing with that 1/2 power. And then g of x is going to be that inside part, 4x squared plus 1, which is a little bit more to do than we've got in the other two problems. All right, so let's see if we can do it. So h of x is equal to the square root. So I'm going to go ahead and write h of x like we did over there. I'm going to write it down here. 4x squared plus 1 to the 1/2, just so we can see it sort of vertically. Now I'm going to take my derivative. So now I'm going to say h prime, derivative of h, is equal to, I've got to do f of x first. So I've got to do this part first. So I'm going to bring down the 1/2. So 1/2, 4x squared plus 1. Now, what's my power? This is where we got to be a little careful. Remember, we've done these before. But remember, I'm subtracting 1 up here to get to my new exponent. So 1/2 minus 1 is negative 1/2. And I've done the f part. Now, you are not done. Remember, you're not done. I have to take the derivative of the g part. And the derivative of the g part, if I think of 4x squared, hopefully we can do our power rule here. And that would be bringing the 2 down, which will make it 8x to the first power, or I can leave it just as 8x. And then if I do a little bit of combining first, I'm going to do this in 2 steps. I'm going to combine my 8 with my 1/2. So 1/2 of 8 would be 4. I'm going to bring my x up front as well. So it's 4x squared plus 1 to the negative 1/2. And if we remember, our negative 1/2 power is going to go to the bottom, or the denominator. And so what I would have, or what I'd be looking for in a multiple choice problem, would be 4x over, because this would become the bottom, the negative 1/2 power would become the bottom, would be the square root, because the 1/2 is still a half, which is a root, except the negative is going to create the bottom for that, and that would be the 4x squared plus 1. So there's 3 examples of the chain rule. Hopefully this gives you a head start if you missed